Hello everyone, my name is Fan Wu, a PhD student supervised by Professor Chiu. I come from the Department of Civil and Environmental Engineering from UA. My research topic is pattern mining from trajectory data for signal coordination evaluation. As we all know, signal coordination is very important for arterial progression, and now there are two kinds of arterial progression quality measure and visualization methods. One is space-time diagram. However, it cannot be applied to a large dataset. The other is Purdue coordination diagram. However, it loses all trajectory information and can only represent one intersection only. So, in my research, I want to quantify and visualize arterial progression quality in a spatial temporal continuous view under different control strategies, and discover travel patterns for vehicles along the arterial. I have chosen a case study site, 23rd Avenue, covering 6 consecutive intersections from 119 Street to 105 Street. I assigned different phase plans for different intersections. I used ground truth traffic volume data. The signals are 4-phase or 3-phase operating with different cycle lengths. I also applied time-varying traffic flow, that means every hour, according to traffic volume data from City of Edmond. And turning ratios are used according to movement data in 2017 from City of Edmond. Here is the geometric information of case study site. It is a 2.4 km long corridor covering 6 consecutive signalized intersections. The speed limit is set as 60 km per hour. It has 2 through lanes for west-east direction and additional turning lanes at intersection approaches. I also set different traffic control strategies of peak period and peak hours. After all environmental settings are done, I simulated that in Shumo. Finally, 3,011 vehicles trajectories from west to east and about 2,000 records for vehicles from east to west over the span of one day were recorded. After all data were prepared, I followed the next 6 steps to do the research. I measured the velocities for all vehicles and extracted spatial temporal data. I applied the cluster analysis and non-negative matrix factorization to get more travel patterns. Finally, to quantify arterial progression well, I have developed a new measure called proportion of arrival gain (PAOG). Here comes the preliminary results. It is a result of class analysis. We can find that almost all vehicles are blocked under fixed control and have a very limited arrive-on-green co-occurrence and high probability of arrive-on rate. And then, under signal coordination control, we can have a higher probability of arrive-on-green co-occurrence and have very limited arrive-on rate co-occurrence. It means smoother arterial progression. This is the non-negative matrix factorization decomposition analysis. The upper 2 figures represent the situation under fixed time control. The lower 2 figures represent the situation under signal coordination. We can find that fixed time control can have a more stable performance than signal coordination. However, signal coordination can provide a higher velocity intensity than that of fixed time control. As to PAOG, if a vehicle meets with a green light at one intersection, the situation is regarded as AOG. So, we can see that signal coordination can provide a higher PAOG than that of fixed time control. So, I think that signal coordination can have a better arterial progression. In summary, we have quantified and visualized arterial progression and developed a new measure to evaluate the smoothness of the arterial progression. We also have some limits of this research, so we recommended that more coordination strategies are applied and more suitable decomposition methodologies are used. This research work was supported by the Natural Sciences and Engineering Research Council of Canada, City of Edmond, and Transport Canada. So thanks these organizations. Thank you very much, and questions are welcome.